All right, number 2. How would you make 155 milliliters of a 0.1 molar copper 2 sulfate solution? I guess I should write that. Solution. Okay, so the question is, how would you make 155 milliliters of a 0.1 molar copper 2 sulfate? And remember from the last slide, or if you didn't know that, copper 2 plus sulfate, put them together, plus 2 minus 2, and this is the compound we're talking about, CuSO4. Well, that's a blue solution. It's a lot like the mini lab we did. So we have a concentration, a molarity, okay, and we have a certain volume of it. Molarity is moles per liters, but we don't need a liter, we need this many milliliters. So we got to find a way to solve for the number of moles per liter. Well, without further ado, let's just get into it. So, remember that 0.1 molar copper sulfate is really 0.1 moles of copper sulfate per 1 liter. That's the capital M. Molarity is N over V, the number of moles over volume. Okay. So, we can solve this. Take a look here. This is our molarity of our solution. This is the ratio of moles to liter. But we don't need 1 liter. If we had 1 liter, it would be 0.1 moles. We have less than that. We have 0.155 liters. We just need to solve for the number of moles. So I'm just setting up a ratio. Moles over liters equals moles over liters. And we can solve for X, moles of copper sulfate. The same would be true if we knew the moles and we wanted to solve for liters. We would just do the same thing. This 0.155 liters, just so you remember, 155 milliliters, here's a conversion factor, times 1 liter, but the units cancel, divided by 1,000 milliliters. It's basically moving the decimal place over 3, and you get 0.155 liters. So this is the volume, this is the number of moles, equals volume under the number of moles. Okay, so to solve for this, all you got to do is cross multiply and divide. This times this divided by this. Let me actually hop down to here. Here's the cross multiply and divide. This times this divided by this, which is just like a conversion factor. Take a look at this. It's liters over liters. The units on top cancel the units on the bottom, and we're converting from liters to moles. What's all this? Well, this molarity is equal to N over V. To find the number of moles, this is what we're trying to find. It's basically, if we rearrange this equation here, so molarity equals N over V, bring the V over here, the number of moles is equal to the volume times the molarity. And that is an equation approach to it, which is really handy because if you have molarity, you could solve, and if you have molarity and moles, you could solve for volume. If you had volume and number of moles, you could just divide those and solve for molarity. So this is a really handy equation. And it just happens to be a conversion factor because the number of moles is equal to the volume times moles over liter. And molarity becomes like a big old conversion factor, converting liters to moles, which is basically what we have here. You see it? Moles is volume times molarity. If that doesn't make sense to you, don't worry. You can always go back to the ratio method or just the straight up conversion method. Think of this in terms of a conversion factor. Do the math. So this is equal to this times this divided by this, and you get this times this divided by that, and you'll end up with 0.0155 moles of copper sulfate. And I'm just gonna let's actually save the significant digits to the end. This is how many moles of copper sulfate we have. But if I'm making the solution, moles is not really useful. I actually have to know how much it weighs. So let's convert that to grams using the molar mass as a conversion factor. It's this many grams in a mole, that many moles, so which is 2.5 grams of copper sulfate. So all I got to do is add 2.5 grams of copper sulfate to water until the volume is 155 milliliter. And you'll end up with the proper number of moles in that many liters, which is according to the same ratio as 0.1 moles per liter. So that's what you got to do, okay? All right, hopefully that was good.